Hello everyone, in this video we are going to solve number question of 48 of GATE 2011 mathematical physics, and the question is, it has two parts. The first part is, you consider a complex function f of z is equal to z of sine z upon z minus pi whole square, then which one of the following statements is correct? So you have been given four statements and you will find out which of the following statements is correct. So basically you have to find the poles and then you have to find out the order of the pole as the options suggest. So first of all, in this kind of functions, wherever you have trigonometric functions in a complex function fz, then the best approach to solve this question is not just putting denominator is equal to 0, but to do the Taylor expansion of this function. So in order to do that, first of all, what you will do is that you have been given a function, and by looking at the function you can assume that the poles must be lying at pi, because z minus pi square is, but so what you'll do is that you will just assume that let's put z minus pi is equal to t. Okay, then your expansion will become z is equal to t plus pi sine of pi plus t upon t square. Now you can just write it as t plus pi. Sine pi plus t is nothing but minus of sine t, and upon t square. Now what you will do is that you can just break it down in two parts: minus t sine t upon t square minus pi sine t upon t square. So it will become sine t upon t minus pi sine t upon t square. Now you know the expansion of sine t, so you can just write it as 1 upon t. Sine t you can write as t minus t cube by 3 factorial plus t5 upon 5 factorial, and so on. Similarly, you can write for the second term sine t also same thing. So t minus t cube by 3 factorial plus t to the power 5 by 5 factorial minus up to infinite terms. Now you can further simplify this. So 1 minus t square upon 3 factorial plus t to the power 4 upon 5 factorial minus up to infinity, minus, you will simplify this will become 1 upon t minus t upon 3 factorial plus t to the power 3 upon 5 factorial, and so on. It will become, okay, sorry, there will be t only. Okay, so yeah, it will look something like this. Okay, now what you'll do is that you cannot further simplify it. Now look for the highest negative power of t in this simplified Taylor expansion of f of t or f of z in this expression. So the highest in this term, there are only positive terms, so no negative t here. Here we have only one power in t which is negative, which is 1 upon t. Rest are all positive power of t. So the highest negative power of t in this given expression is 1 upon t, and the order of this function 1 upon t will give you the pole. Since it has only one power, so it's nothing but t is nothing but what? Z minus pi. So the order is 1. So your pole of fz is at pi, and the order of that pole is 1. So out of this function, the correct answer is fz has a simple pole at z is equal to pi. D is the correct option. Now the second question suggests that consider counterclockwise contour z is equal to 1. So z is equal to 1. Counterclockwise means anti-clockwise, like this. and it is centered at 0 and its radius is 1. So there was what is this contour integral fz dz. Now we know that if the function, if fz is analytic at all points inside a closed curve C, except at some singularities, which lies inside C. So those things, suppose there is some function fz, it is defined, it is analytic, mean it is defined, it doesn't blows up at all points within C, but except some points or some singularities which lies inside C. Then by Cauchy residue theorem, the integral fz dz about this contour, closed contour C, is nothing but plus minus 2 pi I times summation of residue of that function at poles, suppose J, at all poles which lies within this contour C. So we have to find out that suppose you have some function, so this integral is nothing but 2 pi I times the residue of the function at the poles which lies inside the contour C. Now we know that the pole is at pi and pi lies on 3.14. So this pole is lying outside this curve, so there are no residue or no singularity is associated with the function within this closed curve. Therefore this closed integral is nothing but, by Cauchy residue theorem, is nothing but 0. Therefore the right answer for this question is option B. Thank you for watching.